Hi, I'm recording this video because this should have been incorporated in yesterday's lesson at school. However, due to what was yesterday, the fall feast, there was really no effective classes, and we are finishing up this, not the unit but this section on motion, and I definitely want to incorporate this as part of it because on Monday I'm going to jump to a next section. However, this is not super important, but at the same time, it's there will be a question on like on definitely on my test and definitely on the AP tests. Anyway, so the kind of questions that we're going to go over is where the question says, is the particle given some information? Is the particle moving towards or away from the origin? So usually you're given like here's an example. We'll do this example from beginning to end, but you're given a position function, and the question is the particle moving away from the origin at a particular time? Um, so if you know, as an example, if you know that the particle is moving to the right, in other words, like velocity is positive, greater than zero, or I'll say velocity is positive, is the particle moving away or towards the origin? Well, you could pause and think about it, but really, upon really little bit reflection, you should realize, hey, that's not enough information. You need to know where you physically are. So, as an example, if this is a number line and this is origin, if you're on this side of the origin and you have positive velocity, you are moving away, right? However, if you are on this side of the origin and you still have a positive velocity, you are moving towards. So it is a two-prong test, two-factor test, whichever way you want to phrase it. As somebody in class said, oh, it's a double test, right? You're checking for two conditions. So you're checking, let me clear. So you're checking for velocity and velocity, whether it's positive or negative, and position, whether it's positive or negative, what side of the origin you're on. So it's this kind of test. Whereas before, when we had the questions of something speeding up and slowing down, those tests involved velocity and acceleration, right? Like, and we compared their positive and negative values. But right now, we are doing towards or away from the origin, which involve position and velocity. So let's clear this out and kind of do a problem. So let me clear this out. So, all right, let's start. So you're given a position function, right? And the question is the particle moving towards or away from the origin at a particular time? In this case, the word is initially, meaning that time equals zero. So what do we need? Well, we have a position function. We need a velocity function. So velocity of t. In this case, it's pretty straightforward. It's just power rule. So derivative of that is 3t squared plus 18t minus 48. And so going from here, so what is the position? So S of 0 is plug 0 in here, 0 in here, 0 in here. So it's negative 10. So you are like on this side, if this is 0, you're over here somewhere. And the question is, are you going to the left or to the right? So let's do that. So velocity at 0 equals, plug 0 into the velocity function. Clearly, that's 0, 0, so it's negative 48. And I don't care about the value, I don't care about the units here, I just care about the plus minus the direction. So we are, let me see where I'm at. We are traveling in the negative velocity, so we're going in this direction, so this is away. Pretty straightforward once you incorporate both of those facts. All right, let's just do maybe one more. I don't know if I want to do all of this. I want to maybe do another slide after this. All right, so let's, at time t equals 2, so what is my S of 2? And the worst thing about these problems is probably just arithmetic. So let's plug 2 in here, and yeah, and this would be without a calculator, because with a calculator you could, with a calculator you could probably graph this and just kind of make that decision on the spot. Um, but maybe. Yeah, with a graph, you could, are you above the x-axis or below the x-axis, and then judge by the slopes of the tangent lines. Okay, well that's a different, different video, I guess. All right, so s of 2, so let's plug 2 in here. Oh, okay, so this is going to be 2 cubed 8 plus 9 times 4, 32, I think, right? That's a 4, minus 48 times 2 is 96, and minus 10. So in this case, s of that will be, well, it's going to be negative. So this is going to be negative, whatever it is. Doesn't matter what the number is, it's going to be negative, less than 0. So again, you are on this side of um, the origin, but the question is, are you going left, or are you going right or left? So that will be your velocity at 2. So like plug this 2 in here. So um, 3 times 4, right? 3 times 4 is 12, plus 2 in here is 36. Um, and, oh, that's interesting. Okay, okay. I think I could, and minus 48, right? So minus 48. And so this is right here is 48, right? 48. So it's 48 minus 48 equals 0. What does that mean? You're over here, but what are you doing at that moment? Well, the velocity is 0. You're at rest. So technically speaking, well, what's the answer? Neither, right? You're at that moment, you're neither moving towards or moving away from the origin. So this is kind of like a trick question. I don't know if AP does that. I remember kind of making this problem, I guess, last year. I guess I meant to make it a tricky problem, or maybe just randomly made it that way. Anyway, so this is neither. And that probably is the proper answer. It's not like you can't tell. It's neither. It's not moving away or toward, it's standing still at that moment. Okay. And I might as well do the next one, at t equals 10, only because I want to get here. I have away, we have neither, and it'd be nice to have a towards, for symmetry. All right, so let's plug 10 in. So x of 10, and the number's going to get big. Maybe I don't want to do 10. So this is going to be, yeah, 1,000. Well, let's see, 1,000, maybe we could do plus 110 in here. That's 100, so that's 900 minus 480 minus 10. So clearly this is positive, right? Like 1,000, yeah, this is a positive position. So this is positive position, so this is 0. So you're over here somewhere, and the only question is, at that moment, what is your velocity? So let's do a velocity function. Velocity at 10, and where's that velocity? Oh, just a little bit off. So, so this is 10, and here, so this is 300, right? So I'm literally plugging in 10 in here, and then plus 1, plus 10 for plus 180, and then minus 10. I think it was minus 48. Okay, sorry, minus 48. So minus 40. Yeah, I wish I was writing a little smaller to kind of fit in there. So let me do this as my, oh, no. So this is 48. 48. 48. Okay. But the point is, this is clearly, it's going to be a positive value. So it's positive. So you're what? You're on this side, right there, and you have a positive velocity, meaning this is this was, okay, I was hoping to hit a toward, but okay. But that's fine. So notice how they're both away, and they both have positive, well, it's just that one was in a negative direction, but it was on this side of the origin. This one is on the right side of the origin and is traveling in the positive direction, meaning away. Okay, so this and this is both away. And this was neither, so we did not get lucky to get a symmetry going. All right, I'm going to leave this slide. You could just literally, like well, I mean, I think that's probably enough introduction to it. You could, if you wish to practice, just create a problem of your own. Or I don't recall specifically. I'll try to look for delta on this. It probably, yeah, I hope it does contain this skill specifically. I know it's on the AP for a fact, and it will be, this kind of question will be on the unit test. Anyway, let me jump to the next slide because there was something about the next slide I wanted to go over. Okay, yeah, because of the fall feast, and it just kind of at the end of last week, I had to compress a whole bunch of things to get that in, but it's important. All right, so here we go. Several type of problems that are easy to make mistakes on, right? Displacement over interval. Displacement. So yeah, this is a common mistake. Displacement versus distance, right? Like same kind of question over in, but in one case it's the displacement, one case it's distance, and which also lead to another set of problems that are related to each other that are easy to make a mistake. Average velocity over an interval versus average speed over the interval. And these two should be thought of together because average speed depends on distance. So remember, like displacement is change in position, right? So change in s over change in time, which really is like s of final, so like final minus position initial, or sub-zero, divided by time, how long it took you. That is your, sorry, I apologize. This part is the displacement. This part is the displacement. Meanwhile, what I did here was rate of change. So really what I did here was this. This should be down here. That's the average velocity. Whereas um, the displacement is simply change in position, which is S final minus S initial. And you could use letter I in here or whatever for initial. So this is change in position. Whereas distance is a little bit trickier. It really is trickier because it has to do with, turning around, and if the object did not turn around, that both displacement and distance are the same. As you remember in class, we did, I think we spent a decent amount of time on that. Um, so I think I'll just do one or two problems just outright, just to reinforce it, because I don't 100% remember how deeply we covered this in class. So there are two types of problems that can be given to you, and one is using a graph. So here is a graph. Graphing is easy because it's very visual. So let's do that. So what is and frankly, I'm not even going to care about the reading this part, right? Just going to do different aspects of it. So here's a graph. The first thing I'll look is like, well, what does this represent? This is a position function. So think of like if this is an elevator, like like this represents where on which floor the elevator's on. If this is a typical what they call particle moves along the x-axis, yeah, this is going to be like on a number line, like where this particle is, and theoretically because it's going negative direction, positive direction, so that the particle is kind of like doing this back and forth, this kind of thing. And where it is at any one time, like as an example right there, will correspond to some value on the x-axis. All right, I'll clear this out. So here we go. I'm going to treat this as an elevator problem only because it's just so much visual. It's going down, it's going up, it's going down, and so it's so much easier to think of it that way. The final answers will still be the same, it's the values. Anyway, so this is my position function, and if the question is, well, what's my displacement? The displacement will be simply the position final, S final, minus S initial, and in this case, this is the final position. So this, what floor is it on? -5. So -5 minus, and it ended up. Oh, yeah, no, it's good. And it started with 6. So it's on this. So my displacement is -11. Yeah, it went down by 11 floors. Over. Didn't matter what happened in between. It went back. It went it started here, it ended up here at this level, so it lost 11 floors, minus 11. That's displacement. So if I wanted to know like average velocity, which is change in displacement, change in position, so I'm going to call it displacement divided by time. So this would be negative 11 over how long the t from here to 18. So this is 18. Now, the only thing I want to point out here, this is a rate of change. Rate of change. You have something divided by something units. So this is average, like this would be like floors per minute, or whatever these units represent. Meters per second. So if t is in minutes or seconds or hours, so this is time, so let's say minutes, let's just say that, and this is floors, so this would be like this value, negative 11 over 18, and the units will be like floors per minute. So it is, make a connection to the previous skill, it was a slope of a secant line. Slope of the secant line, negative 11 over 18. Floors per minute or meters per second or whatever. Okay. All right, let me undo that. So that answers the displacement and velocity questions, sort of like this side. No, no, this side of it, of the questions. Now let's do this. Distance versus an average speed. So looking at the graph, I'm going to erase all this. It is definitely trickier. Speed is always trickier if there's turning around. And how do I know that the object turned around? There's a couple of ways of seeing it. So let me clear that. Remember, if this is a position function, think of it as you went down to as low as this, then went back up. So velocity here, right, the slope of the tangent line, velocity equals 0. But here we have negative slopes, we have positive slopes. That means it turned around. So at the peaks and valleys, in other words, max and mins, it turned around. It was, the velocity was 0, but it also changed the direction. All right, so let's figure this out. Distance. It's going to get distance traveled, and then if we divide total distance traveled divided by t for time, that'll give us average speed. So let me clear this out so that, all right. So here we go. So distance traveled. The way to treat that is like, well, you started here, and on the first phase of it, you went down to floor number 2. So you started at 6, and you went down by how many floors? By 4. That's your distance. You went by 4 floors. Notice I'm doing a straight line as if it was a straight line. I know it's a curve, but that doesn't matter. You went down by 4 floors. Then you went back up to 5th floor. That means you went up by 3 floors. So this is 3. This is basically the distance is number of floors your elevator covered. So that ends up here. Then what happened? Well, we went down by, well, from 5th floor down to ground level to 0. So that means it's from 5th floor, it's 5 floors down to ground level to 0 floor. And then we went back up to floor number 4. So that's 4. And each time you're like, you're treating this as, whether you went down or up, you're treating that as a absolute value, as a positive number. And then, so that puts us up here, which is really equivalent to this spot, at time equals 13. And then you went down all the way to negative 5 floor, which is 4 floors to the ground level, and then 5. So this is 9. This is 9, all the way to here. So now, what is the distance? You literally add up all these floor traveled. So 4 plus 3, what's the easiest way? This is 8. This and this is 8. This and this is another 8. So that's 16 plus 9 equals 25 total distance. So if the question was what's the total distance traveled, well, the 25, whatever the units are, floors. But the next question, if the next question is, well, what's the average speed? It is distance divided by time. So in this case, distance, which is 25, divided by how long it took us, 18 minutes or hours or whatever this is in min. So I'll just say min, just so that, it's consistent. So that is my average speed. It's a rate of change. So av speed is 25 divided by 18, and just leave it that way. And velocity, I mean, sorry, and the units here are, you know, floors per minute, okay, or meters per second, or whatever the units are, okay. So that's the graphical approach. Yeah, just literally count your, don't care about the actual shape so much. You're like, oh, it just count for like from the top, from your maxes to mins. But notice you also have to figure out, well, like, where do you start? So the endpoints are super important. Um, okay, anyway, so let's move on to like probably the hardest part of this. Well, we'll see in a second. So this is a graphical approach because it's visual, it's nice and easy. What if you were given the same kind of question? Actually, I'm gonna do all finding the distance. If I'm looking for the distance, it's just as easy to go from distance to average speed if the question calls for that, from the distance. So, or if the question calls for average speed, you still have to get the distance first. So I consider this as to be the most difficult part, only because this is just kind of tedious without a calculator. If you're given a calculator, there are will eventually in chapter, I guess, 6, we'll learn the better ways of doing this. Uh, Average, let me see, average, maybe. Yeah, there will be better ways. Okay, but right now I'm not. We're not at liberty to show you the better ways. Okay, so the idea here is you're given this. You're given a position function in terms of a function itself, and we need to know what's the total distance. So we really need those peaks and valleys. We need to know when you turned around, when you. So this really almost immediately this leads to like, well, I need velocity, and from velocity I'm going to create a sign chart. Um, okay, so let's create a sign chart. So what is velocity of t? Given this, I hope that this. Okay, I hope the numbers work out well. So let's start. So this is, you could pause this and do this yourself, but I'm just gonna do it. So it's 12 t squared minus 72 now, 72 t plus 96. So I should have picked an easier problem with easier numbers. Anyway, so now to get the sign chart, we set this equal to 0. This is your velocity. We're setting it equal to 0 when it was at rest, because it's, in order for it to for know when it turned around, we need to like know when it came to a stop, and then change the velocity signs. So now I'm going to factor this. Immediately I recognize that 12 goes into all of them, so it's like if you divide everything by 12, or effectively take 12 outside if as a factor. So this is t squared minus 72, that's 6t, and then 96 divided by 12 is plus 8. Okay, so now we're going to factor this. Now you could, at this point divide by 12 both sides, but that really 12, that's irrelevant in terms of our factoring. Equals 0. This is t, and because this is a plus, that's a minus. Both of these must be minus. Okay. 8, well, clearly it's 2 and 8, 2 and 4, right? Like 2 and 4. So we know that something magical happened at t equals 2 and t equals 4. In other words, it was at rest. But now we're going to create a sign chart to see, well, did it change directions, or was it a bounce? So like And in fact, I know it's going to change direction because just the nature of this is a cubic function, it'll act like this. Like this is its position function. So it never, well, that's not true. That it could have theoretically balanced. Yeah, yeah, yeah. Oh, no, no, I take it back. I take it back. This will, when you take a derivative of this will be, well, this is derivative. Anyway, I'm getting caught up in my what if. Let's not do that. So let's right away create a sign chart. So these are my, oh, why am I doing such a unstraight line? So let me undo that a little straighter. Okay. So my zeros are right there. It's 2 and 4, up 4, and let's create a plus minus sign chart. Now I know that this is a parabola, parabolic shape, and it's going to go through these zeros. But just remember, if you don't see that or it's more complicated, you literally put test points in here. Let's put a 0 in here. So, oh, sorry. So 0. What happens when x equals 0 or t equals 0? This is negative, and so is this, right? -2 and -4. So this is a positive, positive. What happens when you plug 1 in? 3, sorry, 3, some number in between here. 3, put 3 minus 2. This is a positive number. This is a negative number. So overall, this is negative. And of course, this is going to plug big positive number. This is positive, positive. Yeah, and I knew that. I mean, I know it's going to be a parabola going through those zeros, kind of like this, right? Uh, so here's the sign chart. I know it turned around. The object turned here and here, not only because it was at rest, but further because the velocities went from positive velocities, to negative velocities, meaning it's like this. And not only turned around, but I also know this is a relative max. So even though the question's not asking for it, but I'm really tying different concepts together. This is the relative max occurred at t equals 2. And here we have negative slopes and we have positive slopes, and this is a relative min, and this is max. Okay. Again, the question is not asking for that, but yeah, honestly, that's like all those thoughts go through my mind right away. For a second. All right, let me erase the space here, or make space. But now the question becomes pretty difficult, if or tedious, I should say. What is the distance traveled between time 0, right, a time 0 and time 5? So we know the thing turned around, and I don't want to graph this because, uh, well, it's just without a calculator. I definitely don't want to spend time on graphing it. But, so I'm going to create a little table. So at t, so this is t, this is your position, or x of t, and this is going to be like a column distance traveled, okay, between certain moments of in time. So we started at t equals 0, right? Like what was the position? Then we're going to incorporate the first time it turned around, the second time it turned around, and lastly when we end it at 5. I think it was at 5. And unfortunately, I'm going to go back and forth here. Maybe I'll make it a little smaller so that it all fits. Yeah, at 5. Uh, if this is my velocity function, right? So I might erase all this just for space, just so I can bring this up. Because this is my velocity function. Actually, I don't need my velocity function anymore. All I care about is where I was. I need my velocity function to know when I turned around. So obviously you don't erase it, but I'm going to erase this part just so that I can bring this up. And yeah, so this is going to be a little easier, so I don't have to go scroll back and forth. Let's see, that, and a little bit more. Okay, so yeah, I think that'll be a little easier for me. So anyway, so what is my position? So at time t equals 0, it starts at it starts at 8. Like if this is a floor, imagine if this is like representing an elevator. Yes, I know it says along the x-axis, but it's just so, again, so much easier to think of the elevator for me. So it starts at time equals 0. It is start, plug 0, 0, 0. So on 8th floor. Okay. So far you haven't really traveled anything, so you really can't put anything for the distance here. So the moment you plug 2 in here, let's plug 2 in here, it just becomes, I'm going to erase this part as well, just for space. Uh, so at 2, so x of 2 equals, uh, 2 is, so 2, and this is 4 times, so 4 times 8. Oh, I could have done this in my head. All right. So this is 32, right? Oh, okay, here we go. So at 2 in here, that's a 4, so 36 times 4. I'm going to write this out so I don't lose any accidentally. Plus 2 times 96, I think I could do that in my head. That's 192, right? 192, so yeah, 192 plus 8. Okay. Oh, look at these stupid numbers. All right, so this is going to tell me where I ended up, like what floor I'm on at time 2. So let's see, where's the, how do I simplify this arithmetically? This time plus this is 40 plus or minus, well, what is this? This is 7 times 2 is 72. 72 plus, so 140, uh, what am I doing? So 120, 144, yeah, 140, I don't know what, 144, right? And then plus 192, okay. Uh, Doing all this, arithmetic, it's not that difficult. So this is from here to here, this is negative 104 plus 192. So this, the 100s cancel, so 92 minus 4 is 88. So this looks like 88. And I mean, it's not like you could, maybe on the AP test, these questions wouldn't be with such high numbers because it's just arithmetic to slow you down. Okay, but anyway, so that's what that is. So so you're, unless my arithmetic is incorrect, you could catch my mistake if there is any, but I'm gonna presume that is correct. It's not like I ever make mistakes. All right, next one, I'm gonna plug 4 in, so I'm gonna erase this. You could pause and, uh, check my work, but I'm gonna go on. So now plug 4 in, so s or x of 4. Oh, God, I don't want to do this, but 4 in here, this becomes 64 because 4 times 4 times 4 times 4 is 60. Oh, what am I saying? It's 256, right? This part is 64, so it's 256. Why are we doing this? Minus 36 times uh, 16. Why am I doing this? Plus 4 in here. Well, that one's actually easy. 90. I'll write it 96 times 4, but that's kind of easy because that's close to 100. And then plus 8. What is all that going to be? Why did I pick this problem? So this is 500 minus 16. 500, right? I'm sorry, my 400, right? 400 minus 400 minus 16, 400 is 384 plus 8. And what is the, I don't want to do this. Uh, I really don't want to do this. Why did it make me? Let's pretend this is, so we went up. Let's pretend this is 70. Yeah, let's pretend this equals to 70 after all the simplification. Yeah, let's do that. This is 70. And you could put this in a calculator, although this problem would be probably without a calculator. I don't know. I don't know. But let's pretend it's 70. Because the idea here is really, it's my calculation of the distances that's important. But so the idea here, I started on the 8th floor. I went up to 88th floor. That's I went up by 80 floors. Then I went down by looks like 18. Right. Again, this is let's assume it's 70. 18. And let's am I gonna fake this again? Let's put 5 at the end, the 5. So x of 5. Am I really gonna do all this? 5 in here. 5, so 4 times 125, right? 4 times 100, so that's 400 times, so it's 500. The numbers are getting ridiculous. So minus 36 times 25. I don't want to do that. Plus blah, blah, blah. So let's pretend this will get me to 100th floor. Right, let's pretend all this is 100. In other words, this is 100. So you end up on 100th floor. And again, the goal is really to find the distances, not really to get bogged down with pre-algebra arithmetic. So what is the distance that I traveled between here and here? Between this is when I turned around and this is where I just kept going and going and going from now on. So this is 30, right? And what you're doing is you're adding your distances, right? No. So this is 80, um, and it doesn't matter whether you went up or down. It really does not matter here. So think of it even if you was like you went down by 18 floors, right? It is absolute value of it that matters. So all this, can I add this? So 80 plus 30 is 110, 128. And notice it's 128. It's a positive 128. It's like this is what the elevator went through, how many floors in total. This is the total distance, okay, between 0 and 5. Because in between, it did this. It went up, went down, went up. That's what it did. So the total distance is 128. Again, assuming that these numbers, I'm just, assuming these numbers only because I don't want to get bogged down with arithmetic, especially for the purposes of video and making a mistake. Anyway, so if the distance is 128, that's a legitimate answer for this question. So what is the distance traveled over the interval, say 128 floors or meters, whatever. And now what's the average speed over that interval? What's the average speed of the elevator or the person running back and forth or whatever? This is 128 over the time, which on our case was what, 5, right? So 128 over 5. And what's the unit? Well, it's a rate of change. So this is something divided by something. So in this case, floors per minute or whatever, second, and that would be how you do that. So the most tedious part about this was just the arithmetic, but the thoughtful understanding has to be that given this function or given a function, you need to find out when the object turned its motion, turned its direction, which is your up, your max and mins, relative max and mins. That means you have to take a derivative. That means you set it, you take a derivative, set it equal to 0, do the sign chart, and analyze it from there. Yeah, so this is, I don't want to say by far, but most likely the most tedious kind of problem, finding distance traveled using not a graph, but using an equation. All right, I think I'm going to cut this because this was supposed to be a half a lesson or a quick lesson. Meanwhile, it's turning out to be a full-blown lesson. All right, so I am out. See you in class.